Good evening, everyone. Myself, MD Atikur Rahman. I'm a PhD student at University of Bolton. My supervisors are Mamadou and Professor Peter File. My PhD topic or research topic is investigate mechanical and thermal resistant properties of materials for hostile environments, aided by artificial intelligence. Today's presentation would be solely about the hostile environment, and that is the part of my presentation. That's why I revised this one, part one. To present this presentation, I devised this entire segment into some subplots. First, we'll get to know what is the criteria of the environment, followed by atmospheric layers, feature of space, operating systems requirement with respect to the boundary condition, operating systems, and finally, the summary of this one. The aim of this particular presentation is to explore the hostility of this space, which is the operating condition of my thesis. To get into the aim, the entire presentation has been derived into several objectives that will inform the basic or fundamental features of atmospheric layers, followed by features of the boundary condition, low Earth orbit, operating system requirements at low Earth orbit, and finally, some of the examples of typical operating system at LEO. First, if I go to the presentation, I should also mention the try to develop as part of my PhD thesis, which is developing novel bioinspired sustainable composite material suitable for these hostile environments. So, first I will start with the criteria of the environments. The hostile environment means a region or a specified area that can be subjected to life-threatening condition. This life-threatening means it might be extremely high or low thermal or pressurized condition. Furthermore, the abundance of detrimental rays from the solar radiation can be present over there. And last but not the least, lack of oxygen molecule in the air for breathing. So yeah, if you look into the picture, this is the atmospheric layers. So first I should start with the troposphere, which is the layer where all the living organisms such as human, animals, planets, and all other people are living. And this is perhaps the only habitable region in the Earth atmosphere, followed by the stratosphere, where the protective ozone layer is embedded, and that ozone layer is helping the Earth from protecting the Earth actually from the detrimental elements from the solar radiation, followed by the mesosphere, which is perhaps the coldest layers, where all the asteroid or micrometeors coming from the outer space will destroy it because of the air friction. And up to this point, the fascinating part is the ideal gas law sustained. Over this, the ideal gas law started breaking apart. So followed by the troposphere, there is a thermosphere from 85 kilometer to 600 kilometer that is considered as a thermosphere, where the temperature will increase exponentially, and that would get around 2000 degrees centigrade with respect to the solar activity. For the space, after 100 kilometer, which is also considered as a carbon line, we regarded this region as a space because from this point, the sky is visually dark. From 100 to 2000 kilometers is considered as low Earth orbit, where most of the spacecraft are in operation. To get into the features of the space, I would like to start with first, the air pressure decreases drastically with the rising altitude, and by 500 kilometer, it became the changing become like 10 to the power minus 3 to 10 to the power minus 9 torr. So as the density, which become which is ranging between 10 to the power minus 6 to 10 to the power minus 13 kg per meter cube. The temperature, however, increases exponentially, as I mentioned before, in thermosphere, like the thermosphere, and reaches above 1500 degrees centigrade, depending upon the solar activity. Most fascinating part is gravitational acceleration, value becomes around 9.7 meter per second square, but people will feel weightlessness because of the free molecular movement. Apart from that, um, oxygen molecule disassociates. That's when it becomes breaking apart and becomes atomic oxygen that intends to connect to it other molecule or structure, and that become quite prevalent from 150 kilometer to 1000 kilometer. Although some of the books they also or reference also refer this is prevalent up to 800 kilometer. Apart from that, the solar energy consists of around 7% ultraviolet, 46% visible light, and 47% near infrared radiation. I should mention that this infrared radiation is that particular kind of rays because of what skin disease or skin cancer occurred. And the final one is the radiation heat transfer dominates over here, along with the degassing effect because of the vacuum state. Apart from that, the free molecular heating takes place due to the bombardment on the spacecraft by air molecules up to 200 Kelvin, although some of the reference book they mention that this is up to 180 kilometer. Overall, any spacecraft or any system experienced at low Earth orbit, or the heat load that should be composed of solar constant, albedo, and planetary radiation. And that is, of course, depending upon the solar activity. Mathematically or arbitrarily or empirically, whatever we would like to say, system experience heat flux from around 1660 watt per meter square to 317 watt per meter square with respect to solar activity. This solar activity, I mentioned that when the satellite will expose to the full sunlight, on the other part when it will be exposed like the ellipse time. So this is the solar activity I mentioned. System requirements with respect to this boundary condition, or you can say that in space. First, the system operating at low Earth orbit, which is also considered as a circular path, need to maintain around 7.9 kilometer per second velocity, although this velocity is depending upon the altitude from the sea level. The higher the altitude, the velocity would be higher as well. So this is also considered as escape velocity, by the way. Apart from that, orbital debris dominates in this particular region or in this low Earth orbit. Their velocity might be 1 to 15 kilometers per second. However, micrometeoroids are not a major concern in this condition or in this state. Orbital beta angle, which is also considered as a view factor directly connected to the thermal load. Increasing the beta angle decreases the ellipse time. That's when if you increase the beta angle, you would be more exposed to the sunlight. However, in low Earth orbit, the beta angle ranging from 0 to 65 degrees. For reference, International Space Station, the maximum they exposed to, I think, 41 degrees. Apart from that, as I mentioned before, air pressure reduces and temperature increases, so the thermal stress develops on the system. Because of this disparity of this thermal load, system require a special thermal protection system to sustain the adversity of this environment. Satellite in particular incorporate multi-layer insulation system, which is also known as the thermal blanket, to withstand the hostility. Some of the operating system I enclosed over here for as a reference. From my left-hand side, that is the observatory satellite, which is responsible to observe the Earth condition. This is also sometimes used for the military purpose, the navigation purpose, followed by the next one is the International Space Station. This one is used for the scientific experiment apart from the monitoring of the Earth's condition. Furthermore, this is also using as a setting hub. For example, if anyone wants to go to Moon or Mars, and this is the one of the hub they want to lay down. Then third one is the rocket launcher. What's that one? We transfer actually, or transport, I should say, transport some of the components from Earth to the satellite for the maintenance or repairing purpose. Last one is the space drone, which is used to collect the data from the space. Uh, in summary, I want to resonate with the um, modern astrophysicist Dr. Neil deGrasse Tyson. He stated that space is supremely hostile. Um, Even at broad daylight, an observer can see starred up night sky because of insignificant air that can reflect the visible light. Furthermore, the temperature is soaring high, but an observer will feel freezing cold uh, without any special protection system. Actually, nothing can survive over here. I devised this presentation using these references. Um, this all 15 references I included over here. I should also say that I mentioned that I already give this presentation yesterday at my university. So yeah, they uploaded that one. They appreciated my work. I know there is some contingency, there is some time-consuming issue. That's why I did not have much time to upload more information. Anyway, I recorded this one for just as a reference purpose. Thank you very much. Thank you for your appreciation and support.